When it's blinking, it's mute, right? Hmm? Just the problem with this computer. I don't know why it doesn't work. Je redémarre pas depuis tout à l'heure. Alors ça, je sais pas ce que c'est. C'est pas ça qui bloque. C'est quelqu'un en fait qui l'a oublié ici. Il n'y a pas un enseignant peut-être qui a. Peut-être. Donc là, ça. Non, c'est sur Internet. Sur Internet. Il est installé là. Ah oui, là, c'est pas. Alors, Can you hear me online? Can you hear me? Yes or no? Yes. Okay, yeah. Hmm? Because I wanted to change the microphone and I don't- Hmm? Là maintenant ça marche, mais en fait c'est avec mon micro interne, oui. Mais oui, à mon avis. Faut démarrer, c'est pas grave. On verra. Okay, so we can start. Can you hear me, online students? Yes? Okay, good. So for the new students, I don't know if you have some questions regarding what we seen we saw last time about different maybe approaches. If you have some questions, so I can answer now. We discussed a little bit about remember the fingerprint, because I will give you a document on fingerprints, especially a document where it's described how we can process fingerprints. Especially in this document, in fact, it's a book chapter, okay? It's a book chapter that we published just a few years ago. I think it was 3 years ago. I will make a copy of this book chapter, and there will be some main phases, you know, where we try to show how you can process fingerprint, and not just fingerprint, but in general images looking like this. So I will just explain to you. After this, you will find your document in your LMS, in your e-learning platform. Okay, I will upload it very soon, probably this week. So I explained to you what you will find in this document. Okay, so do you see this fingerprint? Because in general, I will use the whiteboard. In general, when you acquire an image of fingerprint, Okay, this is your fingerprint. You start with the main image, which may be in format JPEG or any other format. Okay, what do you know as format for the images? PNG, yeah, what else? Okay, GIF, but we don't use this one. BMP, what else? Maybe TIFF. Okay, so when you use a sensor, you will capture an image, you will store it somewhere, and you will notice that the image has an extension. Okay, one of these extensions. Very often we can use the JPEG. You know what it's called, JPEG? You know what's the difference between JPEG extension and the BMP? Yes? Yeah, it's about compression. It's the way we code the image. When the image has the extension JPEG, what does it mean? It means that it has been compressed. Okay? What does it mean? The compression, it means, you know, the purpose of the compression is basically to reduce the size of images or reduce size of signals or data or anything. Okay, any digital data. And the JPEG format has been developed by the committee, international committee of JPEG, JPEG, and in fact you can access to the website of this organization. So they have described all the different steps to process the images from the beginning, you know, when you capture the image after this different transformation and until you obtain the compressed image. And as I said, the purpose to compress an image is to reduce the size, because if the image at the beginning is not compressed, maybe its size is very important. Okay, when you compress, you try to keep the same information, but you reduce the size. Probably we'll be talking about this in one of the different sessions. Why? Because it's very important to take into account this idea of compression. You have to understand something. The more you compress, the more you lose data or you distort the information. That's why be careful when you compress the image. Very often we say, okay, it's good to compress because I will have much more space, okay, to store the information. But the problem is that you may decrease the quality of the image. And if you decrease the quality of the image and you want to use it for biometrics or something like this, it may be an issue. So that's why it's important to have a look on the format you are using and including also the compression ratio. Just I will give you a quick view about JPEG, maybe in another whiteboard. In fact, when you use the format JPEG, you have the input image. Okay. This input image is, in fact, we can split it to different segments like this. Okay. It's a kind of segmentation. So this is the main image. This is the input. So we segmented like this by different blocks. Each block is an 8 by 8 pixels. Okay. So here you will have 64 pixels of the image, and here you will have 64, and so on. So in fact, we process the image block by block. So you take the first block and you transform it, using what we call the DCT transform. Have you heard about this transform? DCT transform. Yes? What does it mean? DCT? DCT? Discrete cosine transform. So probably you know the FFT or the DFT. Okay, when you see the FFT, it means fast Fourier transform. When you see the DFT, it means discrete Fourier transform. What's the difference between DFT and FFT? Just the algorithm. With the discrete Fourier transform, you transform any data from temporal representation to frequency representation, or from space to frequency. Okay, and the FFT, fast Fourier transform, it provides exactly the same result as the DFT. The only difference is that the FFT is an algorithm to speed up, the execution of the code. So there is no difference in terms of result when you use the FFT and the DFT. And just I remind you that with the FFT, if I give you any signal, any data, and you calculate the FFT, the result will be complex, which means you will obtain what we call the module, and you will obtain a phase. The result is complex. Why I'm talking about this? Because since it's complex, for compression, very often we prefer to use the DCT, because with the DCT is very simple to use. And with the DCT, you don't have a complex result. You have just real result. It means if this is the input signal, when you use the DCT to transform it, okay, to the frequency representation, you will obtain another signal. Where here we have low frequencies, okay, low frequencies, and here you will get high frequencies, okay. So with the DCT, if the input is one signal, you will obtain as output one signal. Why? Because it's described by the equation related to the discrete cosine transform. But with the discrete Fourier transform, the result will be complex. So you will have module and phase. So can you just tell me why very often we prefer to transform data from time to the frequency? What is the purpose of this transform? If as input you have any signal, any data, and you say, okay, let's transform it using the DCT. Do you know why? Look, imagine your signal is over 1000 samples. Okay, you have here samples until 1000. Good. Each sample, of course, is encoded over 1 byte, 2 bytes, whatever. Okay, so you can count, the size of the signal by multiplying the size of each sample by the number of samples. If you have 1,000, okay, if you have, each sample is encoded over 8 bits or 1 byte. Imagine 1 byte. It means if you have a signal of 1,000 samples, you will get 8,000 bytes. Okay? So now, with 1,000 samples, if you transform this information using any transform, for example, the DCT, you will notice something. You will notice that your signal, which was like this at the beginning, will be different in the frequency domain. The shape will be different. And you will notice probably that the energy is much more concentrated in low frequencies. So here we start from 0 until 1,000. Okay, why? Because at the beginning I'm working with 1,000 samples. So when you transform, you will obtain also 1,000 samples. But you will notice that the first samples have high energy, and the more you shift to the right, to the high frequencies, you will notice that the samples here have very low energy. Okay, so for this reason, and very often in practice, what we do, tell me what we can do. If the energy is very low, yeah, we can neglect high frequencies. We say, okay, all the amplitude here are very low, the energy is very low, so we try to keep only the useful information where the energy is much more important. Okay, so instead of dealing with 1,000 samples, we will keep maybe just 100 samples. So if you keep 100 samples instead of 1,000 samples, what does it mean? It's like, yeah, you compressed by 10 instead using 8,000 bytes, if we consider that each sample is 1 byte, or maybe whatever, how you encode your data. But here we can notice that you divided the size by 10. So in fact, when you divide it by 10, since you neglect the high frequencies, you will keep only this information, low frequencies, and this one will be encoded. But you can decide also, to define a threshold. Okay, because you have to define a threshold to say, okay, I will cut at this level, or I will cut at this level, or I will cut at this level. So can you tell me what will be the difference if I cut here, or here, or here? What will be the difference in terms of results? So if I cut my signal here more to the right, it means I would like to keep much more high frequencies. So if I keep more frequencies, it means I will keep more samples. Okay? If I keep more samples, it means I will preserve much more the quality of the signal. Okay, now, and of course, but the problem is that the size of the file that you will obtain is much more important. So if you want to reduce the size of your data, what you can do, you can cut to the left. It means you will remove much more high frequencies. You keep just low frequencies, and By doing so, you will reduce, of course, the size of your file. But at the same time, you will decrease the quality of your signal. So when I say you decrease the quality of the signal, as I said, it depends on the threshold. Okay? So imagine that okay, this is the frequency representation. We keep only one part of the signal, 100 samples. And what should we do to get the initial signal? Pardon? The reverse transform. What will be here? The reverse transform in our case. If you are using the DCT, the reverse transform should be IDCT. Inverse discrete cosine transform. Okay, so the input is signal here. You transform it with DCT, you will obtain this signal. You keep just low frequencies, you will obtain this signal. And after this, I can use the IDCT to obtain the temporal signal that you can compare with the original one. So the more you reduce, you remove the frequencies, the more you decrease the quality of the signal. That's why it's very important to know how reducing or cutting the signal in the frequency domain. Do you have any question? Because transforms are very important in image processing. Very often you have data, and very often you think about transforming the representation. You have a temporal representation, you say, okay, now let's do it in the frequency domain. You can think about FFT, you can think about DCT, and you can think about other transforms we will see in the future. Basically, it will be a wavelet transforms. We will discuss about wavelet transform. Okay, so the idea behind, I don't know if there are some questions from the online students. Is it okay? Okay, good. So as I said, input DCT, you will obtain a new representation. Okay, I have here 1000 samples. I will obtain also 1000 samples. Low frequencies here, high frequencies. I decide to cut the data and I keep just one part. Okay, and you will obtain a signal like this, because here it will be 0. So I remove high frequencies, and after this I can use the IDCT to get temporal signal that I compare with the original one. What's the difference between this one and this one? Can you tell me? In this signal, high frequencies are missing, but the size is optimized, because this one, the original one, as I said, if each sample is 1 byte, you multiply it by 1000, so you have 1000 bytes, okay? And compared to this one, it takes less, in terms of size, it's much more optimized. Why? Because we kept basically, it has been created just by using maybe 100 samples. in the first one you have to save 1000 samples. In the second one you have to save only 100 samples. And always think about the compression ratio. Very often we write it like this: compression ratio. There's a relationship between compression ratio and the quality of your signal. The more you increase the compression ratio, the more you decrease the quality. So here, be careful. What I say here, it's for a signal, but you can apply it for any image. So if you apply it for images, let's create a whiteboard. It will be the same. Input, okay. The DCT using the JPEG will be processed like this, block by block. Okay. Each block, as I said, it's 8 by 8. We apply DCT for each block. And when you apply it for a block is an image, you know, because it's 8 by 8. When you apply it to the image, what will be the difference between the original one and the transformed one? The difference is that in the original one you will have, of course, 8 by 8 pixels. So if you want to store this data, it will take 64 multiply. If it's 1 byte, if each pixel is encoded over 1 byte, so you will get 64 bytes. Okay? So you will have 64 bytes. Now, when you transform your image, what you will notice, I try to do a kind of zoom, okay, of this small block. Okay, it's just a zoom. So I will have 8 by 8, for sure. But if you analyze pixel by pixel, you will just notice something, that the pixels the first pixels here will have a very important value compared to the pixels here. Why? Because in the DCT, it's like you have here frequencies in X direction and in the Y direction. So here you have the frequency 0, 0. What does it mean? It means you have a frequency 0 in the direction X and frequency 0 in the direction Y. So here you have low frequencies and here you have high frequencies. And you will notice using the DCT that all the values here have very low what? Energy, low amplitudes. The energy here is very low. For this reason, if the energy is low, what can we do? Can you propose to me? If here in this zone the energy is very low and here the energy is high, we can keep just the region where the energy is very high, okay, and we neglect all this part. It means we replace it by 0. It means I don't need to keep an image of 8 by 8, which is 64. maybe I will keep just 4x4 or 2x2 or something. Okay, so here it's like I increased the compression ratio, but also when I want to get the original one or to reverse the process, I will lose a little bit the quality. The more you cut here, okay, the more you reduce the quality. So the problem, why I'm talking about this, and what is the relationship between compression and different methods of biometrics, I will explain to you. So it's important to understand that there is this problem. Let me show you. Okay. So as I said, very often the images are compressed because we need to compress the data. Otherwise, it may be an issue, especially for big databases. When you have some big databases of billions, of data, you have to compress. Otherwise, how can you manage all this data? So as I said, you have different formats of compression, and one of them is the JPEG, and you can see when you capture the image, if the extension is JPG, it means it's JPEG. Okay. And JPEG means compression. Compression means that you may lose information. So when you compress a lot your image, we said that compression ratio will be interesting for us, but the quality may be reduced. The problem is that if you apply it on images, you take any image, okay, this is an image, and you apply the DCT, and after this you apply, of course, the thresholding to keep only low frequencies. We said, and after this you use the IDCT to reconstruct the image. So what you will notice that your image has been a little bit distorted, and you will just notice something. You will notice maybe some artifacts on your image. Artifacts due to at the level of each block. I don't know if you paid attention in sometimes when you download some images from internet and you say, oh, the quality is not so good, and you start zooming a little bit the image, and you will notice it looks like you have blocks. Try to do it. It's due to the compression. And even not just images, even when you work with videos, maybe you notice this. You are doing a Skype with someone, okay? You are chatting with someone in Skype, and from time to time you notice that the quality is not so good. At the same time, it looks like you have some blocks in your images. Why? It's just due to the compression, because the compression is too high, and it will distort completely the quality of the image. Yes? Sure, you have the bandwidth, okay? You have your the bandwidth of the internet, it's for sure. But sometimes when the bandwidth becomes very narrow, so the compression tries to, try to compress more and more. And if we compress more and more, you will decrease the quality, and you can notice the blocks on the images. It means, because if your the bandwidth is narrow, okay, it's even logical. You don't have a lot of space, to transmit data. So what you can do, you say, okay, let's compress more the image. But if you compress more, it means you will keep just few data. And if you keep just few data, you will distort the quality. And you will notice the result on the video that you have some different blocks. So that's why sometimes you are chatting using Skype or any other uh, application. Sometimes it's okay, the quality is good, you don't notice, these blocks, but sometimes becomes really horrible, completely horrible, because just you will see just some blocks. So it depends really on your bandwidth. Okay. So can you now understand a little bit the connection between this problem of coding, compression, and the images that you can use for biometrics, for example? What will be the connection here? Yes, imagine you capture a fingerprint. Okay, I have here, okay, imagine here it will be a fingerprint. Okay, so I don't know, maybe the size of the image is 100 kilobytes. I don't know, it's just an example. Okay, and you will compress it, you will modify it, because you have a big database, huge database of billions of persons. It's too much. So you say, okay, I have a good idea. I have to compress all my data, and you will use the JPEG, and you are happy because you save space on your hard disk. Okay, and it will be very flexible when you process the data, when you use algorithms. Why? Because you will use less maybe data, especially if you want to extract some features. And as I said, when you use the IDCT, if you look at your fingerprint, maybe it will look to something completely different. If you compare it to the original one, maybe this one will be blurred because you removed high frequencies. Okay, you have to think about this. When you remove high frequencies, it means you will blur your image. The second point, you will add some artifacts on your image, and using JPEG, you will add, you will see these artifacts on the image. So the quality of the fingerprint will not be so good. So imagine now you want to run your biometric algorithm, for example, for verification or identification, over some images that have been compressed and too much. Okay, compressed too much. So you think that your algorithm is good. Why? Because it works properly on some normal fingerprints. But you forget that your images have been compressed too much and the quality is has been decreased. So when you want, in fingerprint, very often, remember the first slide I showed to you here. Let me show you. Look at this one. in fact, to obtain this image, you have to process the image, the original one. And to process the image, you have to respect a certain number of steps. So to obtain a quality like this, I will show you. Let me just maybe remove this one. I will put this one. Because, you know, at the beginning is the image is in gray level. Gray level. The original one, the image is what it is. But to extract the minutiae, the features from the image, you have to process it, you know. You have to transform the lines, because at the beginning maybe the lines are thick. Right? At the beginning the lines are thick. So what you have to do, you have to process the data, and you will transform all the lines like this to make things easier. Okay? So always you need pre-processing. You need to use some high frequencies filters or low frequencies filters. Why? Because when dealing with fingerprints, you need, what do you need, high frequencies or low frequencies? High frequencies. But if the image is compressed, you will remove the high frequencies. And if you remove a lot of frequencies, so you will blur your image. If you blur your image, it will be a little bit difficult, you will see, difficult, you know, to extract the minutiae, you know. Why? Because high frequencies disappear. That's why the compression format is very important. You have to deal with good quality images. If the image is of bad quality, you will face a lot of issues in terms of programming, especially people who don't program, just integrate. I will give you some libraries and I tell you, okay, these libraries allow you extraction of minutiae from fingerprints. And for sure, maybe it works for good quality images. But if you use as input some bad quality images, here your algorithms will not be useful. Okay? Why? Because the compression will remove the high frequencies. And in fingerprint, if we need, you know, to extract, you know, the minutiae, we need high frequencies. You will take normally, I think on Wednesday, you will start a course with a lecturer. It will be online with someone who is in the US, and the purpose will be just fingerprint. So don't miss the courses. Okay, so you will take these classes about different steps of processing. I will give you also one book chapter about different pre-processing methods, including MATLAB codes that you can use to practice. Okay, so you will have, as I said, one book chapter describing the different phases to process data that look like fingerprints. It means you can apply the methods for any other applications. And we provide you also MATLAB codes. So you can, we show you how to transform a thick line, to a line like this, to extract a skeleton, you know, because very often when you have, for example, an image, this is a person, Okay. Okay. So you use segmentation, and you will detect the region of interest. Why? Because you are interested in this person, and you have your region of interest. And after this, you say, okay, I don't need all this information here. What I need, in fact, because I'm doing biometrics and I need to measure, so I need just to extract skeleton of this from this shape. In fact, you transform it, yeah, something like this. Yeah, you have the head here, legs, and hands or arms. Especially if you need to do some measurements. In fact, you don't need all this information. So you have to transform it to something like this. And to transform it to something like this, you have to use some specific filters. In the book chapter, we give you these different filters that you can use. In fact, yeah, it's explained with some MATLAB codes. Okay? So, what you have to understand the relationship between compressed image and the images used in biometrics. The more you compress, the more you lose high frequencies, the more the extraction become difficult. Okay, so to start, you can use this book chapter. On Wednesday, you will start. You will take some classes on fingerprint, specifically on fingerprints. As I said, it will be online. And after this, there will be other classes, especially for people who are interested in integration. You will take 1 or 2 classes to show you how to integrate or to develop an application using fingerprint reader. I don't know. Normally we have a fingerprint reader here. I don't know if you. Oh, it should be just. Yeah, maybe for online students, I don't know if yeah, this is the fingerprint reader. So you have to understand many things. You have to understand the process in terms of image processing. So you will take some classes about this. As I told you, you have 1 book chapter, and you will take classes with a lecturer from the US. Starts on Wednesday. And you will take other classes to integrate to develop an application using fingerprints. It means, imagine you have 1 software, okay, any software already installed in your computer, and you want to protect the access to the software. So you say, okay, let's protect it using verification, using this kind of fingerprints, okay? And the idea is that you will learn how to install some API, some libraries to make, to protect your application using fingerprints. So it will be with another lecture. It will be a kind of lab. Fingerprints like this. Do you have an idea about the cost? Yeah, it's just a few euros. It depends on the quality. Okay? But at least you will be able to develop your own application using fingerprints and transform it. Even if at the beginning your application is not protected by biometrics, so you can protect it using fingerprint like this. And the lecturer will give you some libraries, APIs to install. He will show you how to install some files to protect any application. So you can transform any application, or you can embed if you word processing, if you want to protect some files, you want to protect some softwares. So here it will not be image processing. Okay, it's important because people, when you deal with biometrics, you have to understand there is one part. Why I cannot use the? Yeah, it works. Okay. When you have a biometric application, you know what's biometric application? You can be involved in this biometric application from data processing point of view. What does it mean? It means you need to know how to process data. So you need signal processing, image processing, video processing, and algorithms in general. Okay, and sometimes you can be involved in the application from implementation point of view. Can you explain me what's the difference between this one and this one? So you can be involved just for data processing or implementation. Yeah, you see, it depends on what you want to do in the future. And I can even add a third section. Can you tell me what will be the third section? I will write it. Hardware. So the hardware is basically the system that you design to capture your data. So here you should be involved much more in electronics. You have to know which device you have to select. And if you want something embedded or something connected to the computer or something like that. So all this part is about hardware and measurement or even capture. It's in one section. If you feel that you are much more connected to electronics, so I think you should be here in this section. If you are connected more in signal processing, image processing, you should be here. Why? Because at this level, we will apply algorithms. And the last one, it will be the implementation and the integration. Here, it's much more for people who are comfortable in what? Programming. So I would like to say here, it's basically computer science or computer engineering until the last connection. What will be the last connection? So you can imagine this scheme. Okay, I have three experts. First one, second one, and third one. The first one is good in electronics. So he will deal with everything which is capture, measurement, choosing the device, and so on. The second one, he should be good in image processing, signal processing, and algorithm development. And he can code, yeah, in MATLAB, in C, C++, whatever, but at least he will think at the level of pixel. How to transform the pixel, how to present the data, how to pre-process, how to process, how to select the data, and so on. So people interested in this field, so they have to understand it's one universe. And after this, once we have the algorithms, we can imagine that this guy can develop algorithm 1, algorithm 2, algorithm 3, and the guy from computer science will maybe transform them to some libraries. Library 1, library 2, library 3, and so on. Because the guy who is here is expert in computer science. Maybe he's not comfortable in image processing, just he understands what will be the input and the output. Can you give me an example about input, output in biometrics? Let's take fingerprint. Okay, fingerprint will be what? Input? Okay, good. What will be? I mean that this block is developed by this guy who is doing image processing. It may be just because for the fingerprint, what should we extract? Minutia. So we can say, okay, I don't need that you explain to me the algorithm that you use to extract minutia. Just give me the minutia. That's all. Yeah. Okay. So you have to understand this scenario. The input here is a fingerprint, and the output is minutia. So the guy here from computer science, in his software, he will use just the function or the library that provides the minutia. And this function or library has been developed by another guy. Okay? So if he has the library to extract minutia, if he has a library to classify data, he will be able to construct his database, he will be able to compare data, he will to do the matching, the evaluation. So the person from computer science can do this. Why? Because people from computer science deal very often with databases. They compare, they take decisions, and so on. So, as I said, this guy developed the algorithm. The function will provide the minutia, and the guy from computer science will integrate or implement an application. So for the moment, we have this person, and before this, we talked about another person from hardware, because the guy from hardware, if he communicates with the guy from image processing, this guy will say, look, it's not my problem which device you use. I want just a good quality fingerprint. It's your problem. Okay? So this guy should think about which device he has to use, and he has to check that the image, the final image, is of good quality. Okay? So you see, you have the first universe, you have the second universe, you have the third universe, and maybe someone is missing here in this scenario. Who? Database management or machine learning? I would like to say, because machine learning and comparison decision can be done by the guy from computer science. It's his work. Okay. But still someone is missing. Who? Sensors? No sensors. It's finished. The sensors are in the beginning. Just I see something here online. Online, can you say something? Just, I would like to say, someone is missing here. Who is this guy? Well, for the moment, I introduce to you this guy. This guy. Where is the other one? This guy. Oh, excuse me. And I'm just the guy which is using this. Well, look. Electronics, data, processor, computer, science, and this one, the user, the most important. Who should use this system? Okay, so this is what you have to understand. So very often this guy should communicate with this guy. Okay, so there will be communication, and for this reason, some people, you know, they may have some profiles between this one and this one. In fact, they can do some electronics, hardware, measurement. At the same time, they can process. They can be between, okay? Because you need to have a good background. You know, someone who is in data processing, it's important for him to understand how some sensors work and something like this. Even it will not be his own job, but at least to communicate with this guy from electronics is very important. You see? So electronics, data processing, after this, computer science, and the user. So I will ask you, each one has a given profile here. So can you just match maybe yourself to one of these 4 persons? Just tell me. Do you see yourself? You are free. You are free. Just tell me if you see yourself here, 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 or here. Yeah, because in general, this is what we see. when you develop an application, and the feedback comes from the user. Okay, so always there is a feedback, and this one, you have a feedback like this. User says, yes, we have this problem, and after this, yeah, this is not my problem, because he would say that the quality is good. So the problem is coming from the guy who programmed the algorithms, and they say, oh, no, my algorithms are good. I checked everything, and I have these curves. So probably there is a bug in, I don't know, and so on. It's like this. That's why I would like to. It's important for you, if you can match one of these persons, if you see yourselves here, or here. So it's important. Can you just tell me to have an idea? Okay, you, the first one. You are much more here. Okay, if you feel that you are here, think about your project. Try to develop a project related to this guy. Okay, acquisition, capture, hardware, measurements, and not especially just biometrics for security. Anything which is related to measurement, capture, and hardware. Okay. The second one. You didn't reply. Do you look like this guy? This guy? This guy? Here? You feel here more comfortable here? Maybe, or if you are here, it means there is a kind of fuzzy logical. You may be here, or maybe you feel a little bit here. So if you say maybe here, it's for sure you are not here. Okay. So third one. Here. So if you think that maybe here, it means you have some skills a little bit with electronics, a little, and a little in programming. Okay, so you feel that you look like this person a little. Maybe in the future you can move, but I'm not sure, because look, if you are not here, you are not here, you are not here, you are not here, so out. I don't know what you are doing here. You have absolutely to find which person you look like, and we can even give them a name. Okay, we try to give them a name, because it's really important, believe me, to say, to understand what you can do in the future. And that's why, depending on your profile, you can work on your projects, and even for your career, it's very important. So the third one, well, you feel that more comfortable in hardware here? Okay. Here, much more programming than okay, but yeah, but finally, do you feel that you are this guy? Okay, this guy with some skills, because you need, because this guy needs to have skills in data processing. Yeah, maybe we can say, okay, 80% of programming and 20% of data processing, and the other guy should have 80% of processing and 20% of computer science. Yeah, they have to overlap, otherwise it may be a problem. Yeah, to communicate always. That's why I said these two persons can communicate, and these two persons can communicate, and after this person can communicate with this one. Okay, and based on the feedback, we can identify if there is any problem. Okay, so for you, if you feel that you are much more here, So think also about your project. Okay, it should be something interface, integration. Yeah. Okay. So people here, yeah, it's much more, yeah, the interface. Asan, you you are more here, skills, yeah, yeah. So in fact, yeah, yeah, your profile is clear. It's yeah, you can between this one and this one. Good. Data processing and more data processing than okay. It's very important because I need feedback because it's a kind of profile. Even if you say I am between this one and this one, you have to say if you feel more comfortable in one part than another, and you can choose your project based on this. Matt, okay, you feel much more in everything which is soft integration, implementation. Okay, good. More computer science, so you feel comfortable in integration, implementation, not with MATLAB, because here, if someone says just I program in MATLAB, just forget it. Why? Because very often users, they don't see MATLAB interfaces. Okay, we need at the end a stand-alone application. This guy should be able to develop an application that you can sell products. Okay, if you develop a MATLAB application and you say I want to sell it, forget it. Okay, yeah, more computer science. Okay, and for you in data processing. Yeah. So it's very important. And for online students, what can you say? Sayed, uh, Izinwa, and Utara. Are you here? Are you here? Oh, yes. Okay, you are here. What will be your answer? What is your profile in this universe? The first one, the second, third, or the fourth? Where are you? It's for sure the project manager. Normally, uh, he's someone who has an experience. He should have a good experience in different fields. Uh, he will be like user for sure. Why? Because here there is the real user and there is the test user. That's why sometimes when you develop software, you need a certification, you need, there are some rules if you want to, to sell your product. And for sure, if you have a product to develop, uh, it's important for the project manager to be, sometimes he acts as a user, sometimes as computer science, and so on. So for sure, at the beginning, you need, the project manager is a user, test user. And after this, maybe the real user is the one who will give some feedbacks, some other feedbacks. Why? Because we think differently. People, they have their habits and many things. Because the user will evaluate not just the functionalities of the product that you develop, but also it may be the color. Why this button is yellow? Why the text is too big or too small or too yeah, of course, because people are different and the user is very important. It's like, for example, you design a car, okay, and you are just a driver. The driver is not supposed to be good in mechanics. He didn't design the engine. He didn't design any electronic device in the car. But he's here to say if he feels comfortable in this car or not, if it's easy to drive the car or not. So the user, when you develop an application, it's exactly the same. You will sell a product and say, okay, so test it. This is the purpose of this product, and just tell me if something is wrong, if you feel comfortable with, if you are satisfied or not. So, and users, when we say user, maybe it's a kind of relation of users, because categories. Because maybe if you are an expert one, you will evaluate the product differently than someone who is just a beginner. So as answer from online students was that for me, I feel more, I'm the third one and some of the second, okay, between 3 and 2. So that's why it's important for your project to think about something which matches, your profile. And you have to think about your project now. For Master 1, students who came from Master 1, if you want, you can keep the same project as the previous one, just try to develop it. Otherwise, you can change the project. For the other students, it's very important to think about your project right now. Okay, if you feel that you are this person, so think about capture, measurement, hardware, and think much more about sensors. Okay, and after this, you have also to, even if you say I'm interested in sensors in this electronics universe, you have to distinguish between two things. Do you want to be a computer researcher, or do you want to be integrate the industry? So here it's important. For data processing, it's the same. You can do data processing, but at the same time, you can think differently. If you want to do research, or if you want to do to be involved in industry. So just can you give me the difference between these two topics, these two objectives? Imagine someone says, yes, I want to work in data processing. And I ask him, do you want to be a researcher, or do you want to integrate the industry? Why this question? Mhm. It's a good answer, indeed. If someone wants to work in data processing, so if in the future he wants to integrate the industry, what he should be aware about the different algorithms, existing algorithms. And he say, okay, I can use this algorithm because it allows me to detect this thing, this thing, this thing. I can use this algorithm, it has been developed by this team, and I can extract these features, and so on. But now, if you want to be a researcher, it's a little bit different because you can say, okay, I know that this algorithm has been developed by other people. Now I would like to modify this algorithm. I would like to improve it. I would like to, to make it working better and better. And here you will think like a researcher. Okay? But of course, very often, in a group, if you have a product to develop, you have a product manager or project manager who should be in touch with different people. That's why it's important. Okay, now it's I said it's the user, but as I said, it can be the test user or the project manager, and he should communicate with all these persons. That's why he should arrange meetings very often, and a flow chart of the project should be clear. He says, okay, you start with this. For example, he will discuss with this guy from electronics, and he says, because this guy, the test user or the project manager, he knows what he is looking for. He says, I want to develop an application for biometrics, and we have to use fingerprint modalities. We want to use it for identification and verification, or maybe he says this application will be used only for identification. So he will try to give all the different functionalities of that should be integrated in the project. Okay, so he will say we need this, we need this, we need this, we need this. Now, in terms of functionalities, after this he says, okay, this part should be developed by this guy. This part should be developed by this guy. And after this, he says, okay, you have to develop this, you have to develop this, but at the same time, you have to communicate. Okay? So this guy will provide some inputs. Outputs, I would like to say, outputs, and it will be an input for the second guy. So the input of someone will be the output of someone else, and the output of someone else will be the input of, and so on. You see, it works like this. And the project manager, since he knows exactly what he wants to develop, he should be, of course, connected to the different persons. And at the same time, if, for example, this guy from electronics, he say there is an issue, he will communicate with the project manager to say, we have this issue, because if we use this sensor, maybe it will solve one problem but not other problems. Or maybe this guy will say, this is the solution, you have to use this sensor. And the project manager says, okay, let me see. And he will check for the price, and he will find that the price is too high and says, no, try to find another solution. We don't want this one. It's your problem, because we cannot buy a sensor at, I don't know, 1,000 euros or something like this. We have to reduce the cost Why? Because the project manager, you know, he should be aware about all the different aspects. Okay? Do you have questions? No? If you want, you can take a break, and after this we continue. Okay? So we'll continue. Do you have any question regarding what we said before? So just to answer one of the questions about the projects, as I said, the first thing to do, you have to identify yourself if you are the first, the second, or the third person, or even the fourth one. For the projects, you can propose. You can propose a project, or otherwise we can propose to you also a project. Okay? You have to identify your profile, and you have to think about what you want to do in the future. Okay? And based on this, you can propose to me a project, and we can discuss about it. Okay? Don't take a lot of time, because we are in October, so you have to decide about your project as soon as possible. And as I said, for the application, you don't have to develop projects just related to biometrics for security. It may be something which is biometrics, which involves, measurements, maybe in any field, medical field, gaming, computer vision, or something like this. Okay, but it's at least for sure. Try to tell me if you are here, or here, and you have to tell me if you want to be a researcher or in the industry. And after this, we will see if it's possible, to make a project by groups or individual. In fact, it may be by group or individual. It depends on what you have to propose. Okay, good. So no question about what we saw here. So we saw this slides. We saw this last time. So you have to understand here, when we talk about biometrics for security and different modalities, sometimes in terms of image processing, you can use some methods, some algorithms that are very close, So someone who is comfortable in image processing, whatever is the modality, he can work on face, he can work on iris, he can work on fingerprint. It's not a problem. If you are someone who is comfortable in image processing, so you can process data, videos, you can develop your algorithms, you can use algorithms coming from someone else. So it shouldn't be a problem. If you are now involved in electronics, very often it will be okay, because if you want to use fingerprint, you have to deal with fingerprint sensors. If you want to deal with face recognition, what will be the sensor? Camera. If you want to use, I don't know, contactless hand biometrics like this one, what should you use? Infrared camera. Okay, so normally someone who is comfortable in electronics, it shouldn't be a problem to use different sensors. Whatever the sensor you use. Why? Because you know how the sensors work. What is the input? What is the output? What are the different issues and things like that. So after this, just you have to think about the application, about the objective to reach. Okay. So we saw this slide. For iris, yeah, we talked a little bit about iris last time. Yeah, you know, for the iris, just we talked a little bit about the processing, and I said the idea is to extract the region of interest from the iris. Okay, so here you have to use some methods of segmentation, and this region of interest, once extracted, because you have to use high pass filter and low pass filter. Once you extract this one, you will invert this one to transform it like simple image. And after this, you have to use some specific filters. And basically, one of the filters that are used are called Gabor filters. And the idea is to extract some parameters, alpha 1, alpha 2, alpha 3, from this image. So these parameters will be signatures. I will provide you one document, which is also a book chapter, in which we describe different steps on how we extract the region of interest and how we extract the different features. Okay, it will be a book chapter and everything will be described. And you will take later, maybe in January, 1 or 2 labs. At least you do it at least once. Okay. I don't know if we discussed about this slide or not last time. Yes. Okay. And you have another modality which is used also for biometrics for security, which is face analysis or face recognition. Do you recognize this guy? Yes. Yeah, he's Laurent, who is managing the e-learning platform. Okay. And I don't know if I have some videos to show you. Face. Yeah, we'll see if I can run. Yeah, just we show you here how such systems work. Okay, what you have here, you can see this face analysis, face recognition system. It's a small box. It's normally equipped by a camera, okay, and sometimes some infrared cameras. So you can see how the user will use it. The end user here, they don't have to make much more effort. They have to be close to the camera. Okay, we detect, you see, we detect the face. Normally the face will be detected here, and we extract some features. So the first thing to do when you deal with face recognition, you know, for this biometrics, I will explain to you. So the first thing when you deal with face recognition, you have to detect you have to detect the face before doing any analysis, before doing any recognition. So you have to detect the face. What does it mean, detecting the face? Capture the face. No, detecting the face, it doesn't mean extracting features. Because you have a person which is working, and sometimes this person is smiling, she's I don't know, doing anything. Maybe this person is not in front of the camera because the camera is here. If the face is in front of the camera, we can get an image like this, where we can see clearly, the eyes, the nose, the mouth, and so on. But the problem is that very often people, they are not in front of the camera, so you may face some problems of what we call pose. The problem with the pose. The problem with the pose is especially when the people are not in front of the camera, and you will obtain an image of not good quality to measure, because in biometrics you need to measure. So if the person, the camera captures something like this, we can see here we have only one eye, okay, and the profile of the person, but it's a little bit difficult, to extract some measurements, for example, distance between eyes, the distance between the eyes and the nose, between the nose and the mouth, and so on. Because very often in some face analysis, face recognition systems, we need to achieve some measurements. So if the person is not in front of the camera, we can say we have a problem of pose, and here it's really difficult to achieve some measurements. In some cases, we can control, we can say, we call this control or controlled environment. What does it mean, controlled environment? Controlled environment, it means you have to give some rules to the user. You have to tell him, to use the biometric system, you have to respect these conditions. For example, you have to tell him you should be in front the camera. We can tell him, don't move during few seconds when you are in front of the camera. Don't turn off the light. Don't do this, don't do this, and so on. So you try to control the environment. Why? Because when you do this, you do it for some specific purposes. Why do we ask the user to, for example, to be in front of the camera, to avoid turning off the light? Can you just tell me why? What is the reason? Why sometimes we try to control the environment, controlled environment, to get best results? It's especially to make the processing easy. Why? Because someone, you design a system, you will capture the data. You are in the field of electronics, you will capture the data, and you are supposed to provide to the guy who should implement the algorithms face, a real face. So if there is a problem, for example, this person is not in front of the camera, and we can see just his profile, and you will provide this image to the guy who will do programming or who develop some algorithms. He says, no, it's very difficult for me. I cannot extract features because this person, I have a problem with pose. This person is not in front. I cannot measure distance between eyes, distance between the eyes and the nose, and so on. So here, the image provided is of bad quality. Okay. So something else. If, for example, the light is not enough, here you will face the same problem because you will provide another image with bad quality, and the person who is developing image processing algorithms will suffer because he has to enhance the quality of the image, and it's not that easy. He has to develop some specific algorithms to make the quality better, and this is not good. So sometimes, okay, so we can control the environment here, and we say, okay, let's take only images when the person is in front the camera. You have to make sure that the light is okay, that there is no noise, and so on. Sometimes you can also control the environment by avoiding what we call the occlusion. Do you know what is the occlusion? Yeah, one object or your object of interest is hidden by another object. So if you deal with face recognition, okay, this is the face, and if, for example, this guy will put his hand on his face, and here we can talk about this is occlusion. Why? Because our region of interest is not clear enough because we hide all this part, and it's not good. Yes, we can. You can face this problem of occlusion in all biometric modalities. So for face analysis, this is a problem of occlusion, but you can have many other cases of occlusion. Can you give me some examples? Pardon? Glasses, for example. If this person is wearing glasses, what will be the problem? The problem is that if our algorithm consists in measuring distances between the eyes and the nose, it will be a problem. So this is occlusion. So why? Because for some algorithms, it's okay. Some algorithms are robust. Even with glasses, we can recognize a little the person. Some other algorithms are very sensitive because it depends what are the features that you will extract. Okay? So give me another case of occlusion. Makeup. In fact, the makeup, I don't know if we have to call it occlusion or not, but the makeup, it's for sure, it's regarded as a contrast. You have the region of interest, you have the eyes, you have the nose, you have everything, but it may be a contrast, especially here too. It depends on the algorithm you are using. If, for example, your algorithm consists in extracting just distance between, these distances, whatever is the makeup, it shouldn't be a problem, right? But if we measure other features, we have to accept other features. For example, this point and this point, this point and this point, it may be a problem for some people, yeah, with some makeup like this, especially those women. So your algorithm will detect this point, and of course, okay. So the algorithm will detect this one, maybe it will detect this one, and it will be a nightmare for your system. And believe me, even now there are some research groups working in this field to recognize the people with and without makeup. So it may be a problem. So also, yeah, so really the sensitivity of your algorithm will depend on what? It depends on the features that you want to extract. Okay, so here it's for the eyes. Okay, but if you want to extract, yeah, something else for the mouth, if you extract features like this point, and you measure, and you will get information like alpha. Okay, so imagine this person is smiling, and when you extract features, you will get this value beta. Alpha is different than beta. So does it mean that we have two different persons? No. So in some situations, we try to control the environment. We say, you don't have to smile. You have to be in front of the camera. The light should be good, and blah, 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 and so on. You control the environment. I don't know if you heard about one story. It's a really recent story. If you ask for a biometric passport now, and you have to provide, of course, photos, and they say the photos should be with a clear background, and they said uh, the size is, yeah, there are some standards. Okay, so no, it should be neutral, without smile, without loading. Why? Have you heard about someone who went to the court because they rejected his photos because he was smiling, and he said, I cannot understand why they rejected my photos just because I was smiling. This is my, yeah, it's something natural. I don't understand why I don't have to smile. And the court rejected his request. What is the reason? The reason is basically it's here because if we need to measure, to extract any biometric information, if the guy is smiling, it may be a problem for some algorithms. Even if we don't use algorithms, even if we do it just manually, okay, it may be a problem. That's why we say, okay, now avoid smiling, because we want to measure. If we need to measure to extract some features from your face, at least we know that all persons are they follow the same rules. So because we know when you smile, okay, so the distance will change, and we ask for natural. Why we ask for a clear background? Yes, basically for segmentation, for, yeah, it will be easy, because if the background is black and your hair is black, here if you use any automatic system for segmentation, we know that it's a big problem. But if it's clear, at least our algorithm will work easily. So you can understand the fact they said, do this, don't do this, don't do this. It's basically to make processing easier when they implemented in the algorithms. Yeah. Sometimes people, they cannot understand it. Say, okay, I don't understand why the background should be white and not blue, not gray, not. It depends, you know. In some engineering, it should be clear. Just the idea is to create contrast, because we know in image processing, if we have a contrast, you can use a simple filter and you can, we can avoid this problem. But do you have an idea? Maybe in the future, maybe one day they will say, don't worry, the background can be anything. Can be anything in the future. So can you think when they will tell us, don't worry about the background? Here we understand that the problem is that it should be, we should have a contrast, basically for two segments, okay? But I imagine one day they will say, don't worry about the background. Like what? If, for example, one day you will take 3D photos, okay? If you take 3D photos, it will be easier to discard the background, you know? Do you understand this? Because why? Or just sorry, I have a problem with I have to connect my computer, otherwise it should turn off. So can you understand? Meanwhile, just think about the 3D capture. Why the 3D capture would allow us to avoid a lot of background. Okay. Do you know how 3D capture works? Yeah. So okay, so this is a person, and this is the background. I don't know, there is a TV here, there is a furniture, anything. And here I use a 3D camera. So when you use a 3D camera, you have an information about the depth. Okay? What does it mean? It means I can have information which is in this area. I can extract information at any distance, you know. So the background, normally, if the background is at 3 meters from the camera, we can say, okay, since we have a 3D image, we can say, okay, all distances that are behind, and this person, imagine this person is at 2 meters 50, okay? So we can decide to filter the information which is here easily, because we take just information that are less than 2.5 meters. You have to understand, with the 3D, you can have kind of layers like this. So you have the depth like this, and you can decide to eliminate any depth here, this one or this one or this one, and you say, okay, let's kept only the information at from 0 until 2.5, and you neglect all the information which is after 2.5. And here, whatever is the background, you can remove it, and you will get not a 2D face, but you will have 3D 3D face. And if you have the 3D face, yeah, of course, because on your passport now, what you have just a 2D, okay? If we want to use biometrics, we can measure information like this. We can extract some other. It doesn't look like a, it looks like a dog, I think, you know? Okay, whatever. Good. So this is what we have now, but with in 3D, you will not have an image, you will have kind of object, 3D object. So your face can be represented in 3D. What does it mean? It means I can see it in front and I can rotate it. You can rotate the face. So do you imagine in your passport we saw a 3D face, which means we can see, we can rotate the face 360 degrees, and at least we can see you in front and the profile. Yes, but this is not a real 3D. It exists, in fact, in some countries for some passports, and I think even it's a French company who designed this system. It's not applied here in France, but used in other countries. But even they say this is not real 3D. It's like hologram, you know. You can, yeah. It's it's yeah. It's like hologram. So if you see if you are in front of the image, you will see something. If you move a little bit, yeah, you can see maybe other information, but it's not enough. It's not. But I'm talking about real 3D. You open your passport, and your passport is completely electronic, or maybe you have just a simple image on your passport, but maybe the officer can access to the 3D, your 3D face. Why? Because in the passport we store the 3D object, not the, and you can rotate it, and you have the profile, and you have, okay. So maybe in the future it will be like this. I was talking about occlusions. So what we saw yeah, we have the occlusion due to the glasses. Yeah, we talked a little bit about the problems with makeup. What else? Can you? Injuries. It depends which kind of injuries, because injuries and injuries. If you say injuries where you lose all this part of your face, maybe. But if you have just some small injuries, it shouldn't be a problem. It depends, in fact, on your algorithm what it will be used for, how we extract features. But there are some other occlusion problems. Yeah, the beard maybe yeah, it's an occlusion. So imagine, yeah, you are enrolled the first time when you provide your photos, yeah, without beard, and after this the occlusion, it means all this part will not be visible. So what's the problem here? The problem is that if you use biometrics and you extract features, and you will do it you will take some labs where you have to extract some features from the face. Sometimes we extract features here, these points. Of course, including we can take some points here for the nose, the same, and eyes. Okay, but the problem is here. So if you have beard, can we extract these points? If you run your algorithms on this face, so the algorithm will maybe detect this shape, okay, and some other points will be detected here that are different than these points. Okay, so do you imagine? So for this reason, this occlusion may sometimes doesn't work, but still I say it depends on the algorithm. If you have another algorithm where you extract only, I don't know, distances between eyes and maybe just it takes into account eyes, nose, and mouth, it shouldn't be a problem. But if your algorithm extracts these features, maybe a big problem. Okay? Something else as occlusion. Someone is writing. You have a question, yeah? Ask your question. I'm not asking to shave your beard, okay? Just I'm talking about. Yeah, okay. Okay, if you have it first, and 1 year later, you shave it, right? This is what you want to say? Okay, you are free to do it. Where's the problem? Okay, so is the question, can we recognize the person or not? Yeah, okay. Okay, good. So everything depends, the idea is that the first time you have a beard and you use the face recognition system with your beard, and later you decided to shade it. Okay, so I will just explain to you, whatever you have a beard or not, you have a face recognition system. This face recognition system is like the system, the device I showed to you in the video. Okay, it's equipped by the camera, and it integrates algorithms, right? Pardon. These algorithms are used to extract features, because in biometrics we need to extract features from images. So when he says the first time it means we call this part enrollment. The first time we use face recognition system or biometric system, we call it enrollment. I will write it. Okay, so this is the first time you give your signature to the system. So if you are wearing, you have a bird, the system, generally some systems, they don't distinguish between if the person is has a beard or not. Okay, there is an algorithm, and this algorithm uh, will provide parameters alpha 1, alpha 2, alpha 3, and so on. As I said, it depends on the algorithm you use. Some algorithms, they extract just some information related to the position of the eyes, nose, mouth, something like this. Some other algorithms, they can integrate the shape of the face. So if the algorithm used is not sensitive to the face shape, even if you shave the beard, it shouldn't be a problem because the algorithm is not sensitive to this region. Okay? Now, if the system is using an algorithm which detects the shape of the face, here maybe you will not be recognized. Okay, your system will work differently. In such a case, what you have to do, you have to enroll yourself once again. Okay, the first time you have a beard, you are recognized, it works properly, no problem. 1 year later, you come back, you use the system, and this system rejects you. What does it mean? It means, yeah, he didn't recognize you. What you have to do, you should be enrolled second time. It's like someone who is maybe uh, fat or slim. You have to understand we have this problem to be fat or slim. You can have a problem like the aging, which is big problem, the aging. If you use your system in 2016 and you come back 30 years later, maybe the system will not recognize you. It depends also on the algorithm. If it's a simple algorithm which extracts just some specific features, it's okay because an algorithm is sensitive to some parameters. It's up to you if you are a programmer or in signal processing, it's up to you to decide to see what are the parameters, the features that are extracted by using this algorithm. So you can choose between different algorithms. Sometimes even we can use some fusion, for different algorithms. So you have to understand sometimes some systems, even if you are enrolled in the database, you will not be recognized. Okay? We call this false rejection. False rejection. And sometimes any biometric system uses what we call false rejection rate. When you buy biometric system, you have to look on this false rejection rate. What does it mean? False rejection rate. False rejection, it means person is enrolled, but the system rejects. Okay? And we have also something which is called false acceptance rate, and it may be very dangerous. If the false acceptance rate is very high, what does it mean? There is a big probability that someone who is not enrolled will be accepted by the system. So false acceptance rate and false rejection rate are two parameters very important to take into account to evaluate performances of your system. Okay, so imagine I give you a project You design your system, you choose a sensor, you choose algorithms, everything is working. It works with 1, 2, or 3 users. It doesn't mean that it will work with all people. So you have to create big database, yes, and you have to say what is the FRR and what will be the FAR, because these parameters, it's kind of indicators about the quality, sensitivity, robustness of the system you develop. Okay, so you can see two biometric devices, fingerprint, face analysis, but you notice that the prices are not the same, and you say, okay, why the prices are not the same? And maybe if you look at the performances, here you can see, yeah, the 8LR and 8LR are not the same. Why? Because maybe in the first one, they have implemented just a simple algorithm to measure just some few parameters that are very sensitive. And in the second one, it's much more complex algorithm to take into account many situations. So always, when you develop an application for biometrics, especially for security, whatever, if it's for face or fingerprint, veins, or anything, you have to provide the FRR and FAR, and you will take just a special class just about this, about evaluation, how to evaluate biometric devices. It's very important. Even when you publish, you develop a method, okay, and you have some results, but to publish, people will say, okay, have you used a database? You will say yes, and they will ask, how many persons in your database? If you say just I work with 2 or 3 persons, they will not, no, it's not enough, because they will say results are not accurate. You have to provide some statistical information. It should be applied on a big database, and we need to know the FAR and FRR. If you provide this, it's an information for us. Why? Because at least we can understand how your your system performs in different situations. Okay, if if I tell you, I give you one system, and the false acceptance rate is around 50%. What does it mean? Yes, yes. If I ask any people, I choose randomly 100 persons. I will tell them, come on, test my system, and I know that the FRI is 50%. So one person over 2 can be accepted. You see the problem? This is a big problem of false acceptance rate. Now, if the false rejection, if I say false rejection is 80%, what does it mean? Yeah, imagine I have enrolled 100 persons. They are supposed to be authorized, to use the system. But the problem is that the FRR is too high. False rejection rate, even if they are enrolled, you will try to access to the system and you will be rejected. 80% of the case, and it's too much. Oh, if you take, for example, with fingerprint, we can reach very um, very low, rates. Yeah, because it's calculated over millions, millions of persons. It's really 0.00000 something. So, and it depends from one system to another one. Hopefully, especially with fingerprints, yeah, we can have some good. Very often, yeah, it works well, but it depends on the between one device and another one. That's why I can maybe I can provide you just to have an idea, because it depends also on the modality. If you use fingerprint and face, it's not, you will not have the same FAR and FRR. Why? Because face, it's much more sensitive. Fingerprints, it's less sensitive. And I can provide you one table to have an idea, but generally it's around 10 power minus something. Just to give you an idea. It's not 30%, it's not 50%. If it's the case, we cannot call it biometric system. Okay? There are many publications where, you know, um, in the tables you have different modalities, and they say, okay, with the iris, you can get this range approximately. With the face, you can reach this range. With the fingerprint, this range, and so on. So very often, when you use a fingerprint or iris, it's close. But with face or maybe something else, it's a little bit different. But at least it gives you an idea. It will help you on selecting the modality that you want to use. It depends if you want to use it just for, a small group of persons, or maybe if you want to use it in an airport where, we have millions and billions of people. It's not the same. The cost is not the same. The ease of use is not the same, and really it depends on the application you want to use. So, but at least you should be aware about this parameters stuff. This evaluation of performances is very, very important. Okay. I don't know if we're. Do you have another occlusion problem that may occur? What do you want to put? Hat. Here the same. If you use a hat and if your algorithm is not sensitive to this part, uh, this is a hat, your hat here, but maybe your algorithm will extract only parameters from here. So even if you're wearing the hat, it shouldn't be a problem. Okay, why? Because your algorithm will not extract any parameter from this region. If the algorithm is measuring some information, for example, from the top to the bottom here, it's for sure, yeah, it will be sensitive. So what you have to check the algorithm, how it works. Pardon? In some cases, twins. Uh, there are many research, regarding the twins. You can find some differences, but here also it depends also on the algorithm. If you measure just few parameters, for example, from the face, you extract just alpha, beta, and gamma. If you take you take twins, maybe you will find exactly the same parameters. But the more you increase the parameters, the more you will find some differences. Some algorithms are robust and other algorithms are not robust. If you work with one parameter, maybe it's not enough. The more you increase the parameters, the more you deal with robust algorithms, and you can maybe even distinguish between twins. have question. B over 10% are rejected. I didn't understand what you mean. I don't understand what you mean. Okay, well maybe. What can we say about the yeah, another occlusion case? If you put a kind of scarf or something like this to hide one part of your face, okay, and here you add here a scarf. When you apply an algorithm, so maybe the algorithm will act only on this region, but it's impossible, yeah, to extract some other parameters. And here we call it also an occlusion. Okay, it's an occlusion. So some algorithms are sensitive and other algorithms are not sensitive. Okay. What can we add about occlusion? Yeah, we can imagine other cases of occlusions. As I said, yeah, you know, the aging is another problem. The aging. Okay. When you are enrolled now and you want to use the same system 20 years later, maybe here, yeah, maybe a problem, especially for kids. You know, for the kids, because you know, for adults in general, yeah, you know, the distances between eyes, nose, the mouth will not change. But for kids, it will change over time. So that's why using biometrics with kids is sometimes critical. And people should enroll themselves very often because you have to update the system. Okay? Okay, no questions? So next time, on Thursday, you will start. I have last question. How many? Two. Yeah, we cannot say there's absolutely no rule. No rule to say you have to enroll yourself after 6 months or if you are using, for example, the fingerprint, normally the fingerprint will never change, except if you have some problems of injuries, okay? Okay, or maybe some disease. In case of some disease, some cancers, here, yeah, maybe it will change. For the face, as I said, it depends on the occlusion. If, for example, you take weight, also if there's a problem of aging, once you are not recognized by the system, it means you have to be enrolled once again. So we cannot say you have to do it each 6 months or something like this. No, but you have to understand that when you design a system, you can automatically say each 6 months I have to use to update the data. Okay, it should be included in the algorithm. We have an idea about how the face change. We have an idea about fingerprints. It's not the same. The iris, yeah, it doesn't change except in some case of some disease. This is what I said. If you face some disease, in such case you have to update your system. Plastic surgery for face analysis, face recognition. Yes, you have to update the system. So it's a kind of case by case. It's not, you know, and in your system you can modify it as you like, depending on the application. Okay. Yeah, for your project, yeah, you can propose. Yeah, no problem. You can propose a project and we will see. Okay, no problem. Good. So as I said, on Thursday, you will take a class online on fingerprints, uh, all the different methods of, yeah, fingerprints. Maybe you will see some problems of attacks and things like that. Okay. So thank you very much, and see you next time. Bye.